This is the video for the pre-lab for Lab 5, Will I Stay or Will I Go? An application of probability distributions. Before you go to lab, make sure that you read the lab and the lab manual. Read pages 33 to 40. A review of the material you'll need from lecture that's used in this lab is a review of tree diagrams. Remember that the first set of boxes represent what you could get on the first attempt, either the event A or not A. The two events listed in the tree diagram for the first outcome must be mutually exclusive and collectively exhaustive. Make sure that these outcomes are unique. You should never have the same outcome listed more than once in a column for a set of branches. The second set of boxes represent what you could get on the second attempt, based off of what you got on the first attempt. So our second outcomes could be B or not B. Our first box represents the outcome of event B given that A has already occurred. The next box represents the outcome of event not B given that A has already occurred. Then the outcome of event B given not A has occurred, and the outcome of event not B given not A has already occurred. So remember, your second set of boxes represent conditional probabilities. The event of something happening given the first outcome is already known. Now, on each of the branches you can list the probabilities. The probabilities on the branches to the first outcome are simple probabilities. The likelihood of the first event A occurring, or the event not A occurring. Remember that the complement, the event of not A occurring, is simply 1 minus the probability that it did occur. So if you know the probability of A, you can find the probability of its complement by subtracting that from 1. The probabilities on the branches starting at another outcome are conditional, based on what's given in the first outcome. So the probability on this branch up here would be the probability of B given that A has already occurred. The probability of not B given A has already occurred. The probabilities of two events happening, which are called the intersections, are found by multiplying the probabilities on the branches. The likelihood of event A and event B occurring is the probability of A times the probability of B given A. So you multiply your probabilities on your branches to find the intersections. Also, what you'll need in this lab is you'll need some material from Chapter 6. Probability distributions. Probability distributions look like this diagram on the left. You have a column for what X can be and the column for how likely each outcome of X is. So column X represents the values X can take. P of X represents the probability of each of these values. The values of P of X must be between 0 and 1. So every number in your second column over here must be between 0 and 1. And the sum of the column must equal 1. When you add up your probabilities column, it must sum to 1. For example, profits. Assume a company had a 75% chance of making a profit of $20. If the company does not profit $20, then they lose $5. So the company will either make $20 or lose $5. And traditionally you do write them in ascending order, but it doesn't matter. So the outcomes for the company's profits are either minus $5 or adding $20. And then you would just list the probabilities. The likelihood of profiting $20 is 0.75 because it had a 75% chance. The other one must be 0.25 because remember this column must sum to 1. You can also find the mean of a probability distribution like this by taking each value of x times its probability and adding the values together. That will give us the weighted average, which is the average over a long period of time. For our example, our average would be 13.75, meaning the company should have an average profit of $13.75 over a long period of time. Remember, you must turn in completely filled in copies of tables and figures from pages 37 through 39, in addition to the questions at the end of the lab, in order to get full credit. Don't lose points on your lab because you didn't turn in all your tables and your graphs completely filled in. Also, don't forget to do the pre-lab quiz.